Hi everybody. I'm going to tell you about the project EENLP, Cross-lingual Eastern European Index. This is a joint work with Alexey Tikhonov, Alex Maklashov, Andrey Manoshin, that's me, George Dima, Rika Shirhati, Mohammed Sadek Hossein Asif, and Matt Shadi. Let us begin. First of all, I want to mention a few general things about NLP that might be useful later. First thing is multilingual transformer language-based model. Well know that transformers conquered the NLP world in the recent years. And on the screen you see a few bright examples as BERT, multilingual distilled BERT, and XM Roberta. Multilingual BERT, multilingual distilled BERT, and XM Roberta are multilingual languages which have a few very interesting properties. One of them is the thing called a zero-shot cross-lingual transfer. What does it mean? Imagine we have some initialized models here, and we have two piles of text. For example, one pile of text is in English, the other pile is in Armenian. And if we pre-train our big language model on these two piles of unstructured text, next we have some downstream task here, which we need to fine-tune on. For example, it will be sentiment analysis, sentiment detection task, which is simply classification whether the sentence carries good sentiment, bad, or neutral. Yeah? Which is often the case, we have labeled data only on English language. If we fine-tune the model only on English language with these English language pairs, data pairs, we can discover that on other languages, which a multilingual model is trained on, in other languages, model will have the same capabilities as if it was fine-tuned on the Armenian language, for example. That means that when we trained on English data pairs, we have as well infer on Russian data pairs, Armenian data pairs, and whatever the language model was originally pre-trained on. Yeah. Next step is a common sense reasoning set of tasks. It is key tasks in NLP world, and there are quite a few examples of these tasks. Let's talk about NLE, for example. NLE, it is kind of classification task when we are given two sentences and we want to predict the relation between them, whether it is entailment, whether the sentences contradict each other, or whether they are not related at all. And on such tasks, we later evaluate our models that we will be training. Next, few more words about this cross-lingual transfer learning. It is the quality of this cross-lingual transfer depends on very large amount of things. Some authors speculate that it might be similarities of languages, shares of model, vocabulary, and almost very large amount of things that could impact quality of data set, quality of similarity of languages, and that kind of stuff. Yeah. The thing is that most multilingual models that we have now are often represented on only high-resource languages, such as English language, such as German, such as French, and so on. And we won't have not only these high-resource languages, but also we want label data for low-resource languages, which help in some business tasks, which will have in the multilingual research field. This is a problem right now, which we intend to solve. And next thing that we mainly focused on Eastern European languages. There are numerous languages in Eastern Europe, and we focused only on these languages because this project was first started as a part of summer school by DeepMind, EENLP 2021, and later we even published a paper about this The paper was published on LREC and in this June, if I remember correctly. And finally to our project, we've made these contributions. First, we built a broad dataset index. We collected all datasets that we can find on focused on low resource languages and indexed them in a very convenient way, which I will show you later. The same things we did to the models. We collected a large amount of models, BERT-like, GPT-like, probabilistic models, and so on, and frozen embedding models. And we built a few baselines with, sorry, baseline too late or too early. We also built benchmarks. From these collected datasets, we joined datasets with similar tasks to build our new, more broad datasets that cover more and more languages. And with these models and these benchmarks, we created a few baselines. Okay, let's start with the dataset index. We collect the total number of collected datasets is more than 90. We can see them in a minute. Yeah. If you go to with the link, you can see this index. On the rows, you have various languages, Albanian, Armenian, and so on. And here you have tasks. These languages and tasks are systemated in a very convenient way. For example, you want to solve there in Armenian, just go to this link and see what's going on. The same thing we did to the, I closed my presentation. Wait a minute. Okay. The same thing we did to the models. The total number of collected models is more than 60. And specifically, we collected more than 20 language-specific BERT-like models. And you can go to the link too, and we'll see the similar structure. Models and the types of models. You can find almost anything that exists here, or anything that existed to this time. Yeah, and very interesting thing also is that we made it very, very easy to contribute. If you want to photo it later or now. And we also made it, all of these things are very easy to contribute. You can just follow the guidelines. To contribute, you just have to fork the repository, add an UML file about the data set and the model in the folder, and these indexes will update automatically. That's all you need to do. And we created a few benchmarks with these tasks from these models, or from not models, for these data sets. And we evaluated these benchmarks. When we evaluated a few popular models, multilingual models on these benchmarks, the models are multilingual BERT, multilingual distilled BERT, and XLM Roberta. And as a baseline, we have just simple BERT, and we can see that indeed there is the thing that named cross-lingual transfer, because BERT, for example, didn't learn anything. This task is news categorization, by the way, where we just classifying some news. And also the interesting thing that we can notice is that distillation greatly reduces performance of cross-lingual transfer. For example, you can see that on English language, quality did not drop too much, only for 1 and something %. But on other languages, we can see 7, 11, and so on. So distillation is very bad for cross-lingual transfer. And same things for paraphrase detection, new sentiment detection tasks. Also, a few interesting things about new sentiment detection task. If you analyze this table, you might find that for some pairs of languages, cross-lingual transfer works really well because these languages are semantically similar because they're from the same language family or whatever. Okay, the same thing we can say for the Twitter sentiment detection task. Also, we can notice that almost everywhere in such hard tasks as sentiment detection or NLE, XML Roberta is a winner. Yeah, and let's go to the conclusions. What we can say is that multilingual training is a key to zero-shot cross-lingual transfer. Distillation works not that good on cross-lingual transfer. XML Roberta is a very good model, one of the models that can achieve nice performance with this cross-lingual transfer. And quality of transfer is impacted by similarity of languages. And in total, we present indexes, we present benchmarks, and we present evaluations of some popular models on these benchmarks. Some acknowledgements. Sorry. We want to give thanks to EEML organizers Razvan and Pyorika, and our mentor Tomasz Miglov. Thanks for your attention, and if you have any questions, please ask them.
Just a quick question.
Okay.
Did you train BERTs after combining the data sets together?
Yes. We created new benchmarks. For example, let's say about miscategorization. We created a new benchmark that focused on miscategorization from these data sets. We combined, in this case, eight. I can count, yeah. We combined 8 data sets, and we trained on these data sets models on distilled BERT, XML layer, and yeah, that's this thing.
Did you also try the translations?
No, we didn't tackle translation. We tackled only these classification type tasks. Because translation, we actually might work with translation, but we decided not to because all our data sets are focused on some kinds of classification. Because for good translation, you often need to very large amount of data sets, I suppose, and very large data sets.
So all of them were the monolingual data sets, right? They weren't like a pair of the translation, or all of them were monolingual, right? Like the classification tasks, right?
Sorry, can you...
All the data sets that you had had labels on, right? There wasn't any pair like the translation pairs.
No. There, language pre-training was done only on the completely unstructured, unsorted, unparalleled data sets. And even these unsorted data sets, when we train model on, have capability to do cross-lingual transfer. And also this is, as far as I know, quite unsolved question, why do we even have this cross-lingual transfer? Because we don't have translation pairs. But turned out that model, even such models as multilingual BERT, XMLR, have the capability to understand what do we want on other languages. And this is interesting also because XMLR, for example, the biggest model of these three, now considered is not that big because we have GPT-3, Chinchilla, Megatron, and blah, blah, blah.
And the last question, did you try transfer learning to using this MBERT for another task? Like after translation, this one?
No, from one task to another, we didn't try transfer learning because no, we took only one pre-trained models. We took one downstream tasks, and we transferred our pre-trained models to this downstream.
Just on top of curiosity, do you have any idea if they're working in another task? Is it better or not, right, after combination?
Another tasks? Do you mean another tasks such as question answering?
No, like transferring. Or even another task.
Okay, information trivia. I think that they might be. But I'm not entirely sure, to be honest, because we didn't evaluate on such tasks. we will it only on NLP data, we will only on classification type tasks, and you use only BERT-like models because they're said to be good at classification.
Thanks.
Any other questions? Thank you for your.
Hello, everyone. As they said, today we're going to talk about what can your Telegram and more specifically your Telegram data tell about you. I think many of us use Telegram in messaging in daily life. Can we just like do the hand gesture if we use? Oh, the absolute majority kind of uses Telegram, and the best part of Telegram is that. In comparison with other messengers, it allows us, the regular users, without opening any other kinds of accounts, to export our data from Telegram. And here we can see how we can harness that data and what statistics and what interesting facts we can get from analyzing our Telegram data. Let's go. This is an ordinary guy. Let's name him Toros. And Toros obviously uses Telegram. What he does in his free time is very similar to what all of us do. Toros does some chit-chatting with his friends, also exchanges memes, flirts, or discusses some important startup ideas, and so on. So generally speaking, Toros, we can see some image of Toros kind of in just based on his Telegram interactions. And the best part of Telegram is that Toros is not the only one. There are about 700 million people who use Telegram. I mean, it is the number of active users in Telegram. So you can imagine how big that data is and how many people can get interesting insights from their Telegram accounts. For example, like what are the simplest things we can get from analyzing Toros' conversations and so on? We can know what are his favorite words. Like about everything about his vocabulary, his lexicon, how it has evaluated during months or even in very small periods. We can figure out who are Toros's close friends, or at least those who are on Telegram, like who he loves to spend time chatting with, and which hours does he spend with them, and with that said, daily screen time, like maybe he uses 3 hours a day his Telegram. We can find out his most emotional chats, like which are the most funny chats, which are who is his crush, kind of, which are lovely chats. When is he surprised? When is he angry? We can also know who congratulated his birthday first, and usually who starts the convo. Is he kind of extrovert or introvert? If we may let ourselves imagine that, and so on. And also, when is his sleeping time? Maybe we all can agree that we use Telegram before our sleep. And I mean, if we are active Telegram users, or at least Messenger users, we actively chat before sleeping. And also when we wake up, it is, well, usually it's one of the first things all of us do. So what do we need for that? An ordinary Toros will ask. We need data, or something like data-driven automatic Telegram analyzer. Here we go, Neplo Telegram Analyzer. Behold, Neplo, or we may pronounce it Neplo. I don't know what is the correct pronunciation. So this is Neplo. Now we're going to talk about what is Neplo, and we're going to see how it performs real time. So first, Neplo is an open source Python also online deployed, so we can everyone can use it from our laptops right now without any further installation or something. And it's also free. And I think these are the four kind of main points that NAPLO can go with. What data do we give? Actually, Telegram has, as I've said, it has a wonderful feature. It helps us. It lets us to export our data, and it is a single file, like a 50 megabyte file, which contains all of our conversations and chats and messages. And when I say messages, we mean that NAPLO uses the content of these messages, what is written there, the timestamps where each message is sent and received, and also the types of messages. I mean, stickers, emojis, or images, and so on. And maybe we can agree that we can get some interesting insights from that kind of data. We'll see that soon. And all we need to, all Taurus needs to do is to export this data from Telegram in JSON format. It is a 1 minute thing, and sometimes it takes even less than 1 minute. Upload it to NAPLO, and he can then play with tools and magic buttons and see some insights about his life that many of us haven't known. Well, Taurus will ask where can I find this kind of data, this kind of analysis about my data. As I've said, NAPLO is open source. It doesn't take your data, and we don't use it or something. Let's follow this link and see what NAPLO can do. Oh. Oh yeah, I guess I know what's the problem. Here you can see the repository at GitHub. So here's NAPLO. First we upload our JSON file, and I've brought my own data, or at least some part of it. We can see it's 25 megabytes. Let's wait for 5 seconds. 5 seconds, and I'll show you all the features NAPLO obtains. Easy peasy. It does some pre-processing of this data. I mean, the code is open source, and you can see what it does. Great, it's now processed even successfully. Let me first scroll and show you the features. I mean, there are not so many, but certainly some of them are kind of relevant. For example, most notable days. What can most notable days mean in the context? In this context, he can see some kind of options we can set. Let's go on. For example, this is the simplest thing NAPLO can tell us. It says your longest non-stop conversation by count happened on this day, and the same day it was also the lengthiest talking, and it tells us when did we spend the longest active hours on Telegram. My first message was sent on 2018, and my record on sent messages is on this date, and of received messages on that date, and so on. It's easily adjustable. We can kind of play with all these parameters. Maybe we don't want to have the data across all of my chat history. We can choose some of my kind of friends, people I chat with. We can select Albert, for example, and it will filter out and leave us only with the data from my and Albert's conversation. We can also have other people, and now let's go on trying the, kind of the most interesting thing it can give us. I believe we are kind of interested with the screen time, like when do I sleep and so on. Let's delete this. Yeah, so we just select screen time per day. And it goes on and on from kind of every day. Obviously, we don't need this kind of data. Oh, we can see that something is not right. Okay, let's try another thing. This will get fixed. Longest gap in a chat. This one amazed me because this is showed. This one showed me which person I used to talk in the past and who disappeared for the longest gap, kind of. We can see that this user named, you can see Arata, I used to chat with him kind of 2 years ago, and then he disappeared, and he is disappeared for 652 days. Another thing we can see maybe what are the most or least probable words to use in a chat. For example, we can see, oh, this is kind of personal data actually, but this is my brother, he will not resent. Okay, the most probable things, most probable words are right to him, it's kind of his name, and okay, whoever understands Armenian can know it's kind of oh, okay, for humiliation, like something like boss, home, mommy, grandma, his name, and so on. Actually, we can go into details, but let's move the technical part and more concentrate on, okay, for example, word popularity by chats. For example, we can just input a word, for example, Python. Let's say Python and press enter. It filters out the messages sent by me or to me. I guess this is some problem about my data. Okay, I will inspect it and it will get fixed. Maximum conversations held at once. You can see. Well, based on this data, in a span of 15 minutes, I have a couple of months ago, talked to 3 people at once, exchanging 8 messages. This is not so impressive, but actually having a conversation with 3 distinct people is, well, somewhat surprising, to say the least. Typical startings and endings of a conversation, like how do people greet each other? Oh, here we can see this is, and again, for everybody who understands Armenian, this may be funny, and who doesn't understand it says kind of good morning, good day. There are some vocatives here, like yes and so on. We can. What is interesting is that when we filter out one chat, kind of a person we talk every day to, and it will tell us what are the most famous, kind of the most popular ways we start the conversation or end the conversation, kind of good night or good morning. We can do everything. In a nutshell, we can do everything related to words, to kind of my vocabulary. We can see the popularity, the word usage per day, week, month, year. What do I type when the day just begins and the end of the days? We can see. Oh, this one here is kind of daily message count over time. Okay, maybe this one will take somewhat longer, but okay. Here we see a graph. Obviously, we can filter out and just leave 2 or 3 people there to see whom do we chat with most. As the title says, it filters out the daily message count over time. Like here we can see the date, and here are the recipients or the people who sent us messages. and here's the count. We can do the same trick with time. Like how many hours have I spent talking to someone else, and just like we did with the count. Word of the day, or week, or month, or year, we can, well, for it to be more interesting, we can filter out by month. Okay, well, let's filter out by month. We can see the most popular words on each month. Well, usually it's not so interesting, I'm not gonna lie, but it's, yeah, it's sometimes, yeah, it's sometimes, they tell me I have 1 minute, just 1 minute. So there are about 30 features. You can explore all of them, and obviously we cannot concentrate on all of them. We can see emotions by chat. I guess this is, as you notice, on my data of about 3 years, the NEPLO words, well, considerably fast, and we can just try all of these features in a couple of minutes or so. For example, emotions by chat, here we have we can set a filter for it not to display all messages. Oh, okay. It just, okay, it got reloaded. That's maybe my bad. My time is over, or, but I'll be happy to answer any questions if there are, and we can go into details or just, yeah.
Can we get information on your friends?
Well, yes. As we have seen, there are commonly filters like messages sent by me or sent to me. Yeah.
For your friends, and you get that JSON file.
Just ask them for their JSON file, and the rest will be done by NEPLO. I mean, I will try it. For my friends who are not here, I will try to ask them for their files, and we'll try that way.
Somewhere where you can download.
Well, actually, the purpose of kind of privacy is that they don't give their messages to us, unfortunately. Yeah, please.
So I suggest you to put in the application notifications because it will increase probable users. For example, to notify the person how many hours he spent, like for time management, and also if your networking is growing. So you don't not about spending time, about how many messages you sent to how many people. So I think this will increase the users. And another question: why NEPLO and with this tilde character?
Oh yeah, actually a good insight and a good question. Thank you for your insight. I've done something like that, like counting the persons you're in conversation with, but then abandoned that idea. And maybe if there's need, we can add that feature back. And about name, well, there is, again, maybe Armenian population would be familiar with that. There's a Telegram sticker pack which features Gor Vartanyan and or one of his TV series, and there is a sticker. One of the stickers is Gor lying in bed, and there's a caption "Было неплохо," which translates to quite good or something like that. So NEPLO is the first 5 letters, kind of неплохо. And then this, yeah, this tilde above N is from Spanish. They have letter like that. You may see words like Española or something like that, spelled with this letter. So that's it.
For me, I don't catch the point. What is the purpose to know who is my best friend or who can be my best friend? But for another person, maybe it can be proposed. I don't know. To know which girls spend more time to sending messages. I don't know. Interesting,
yeah.
interesting. Thank you.
Thank you.